Okay, so I'm here at the Sale Water Park in Manchester, and one phenomena which you can see very clearly are these waves that appear like sinusoidal functions. And what happens is that the waves are coming up to the surface, which is interesting because it describes the direction of propagation of the wave, which is towards the edge, the curb. What's interesting, however, is that if you see a piece or a particle or there was a dead fish that was floating just over here, it wasn't moving with the direction of the propagation of the wave. Rather, it was actually just bobbing up and down in a kind of oscillatory fashion, going like this, where the kinetic energy was minimum at the peak of the cycle. It was accelerating towards the center, and then it was decelerating towards the bottom, and then it kind of repeated this pattern again. So it was kind of going up and down as the propagation of the wave was moving towards the surface to the curb over here. So what you have is that you have this interchange of energy going from a maximum kinetic energy at the center of its displacement, and that's when the potential energy is maximum. So what you have is this transition between kinetic and potential energy of this particle on any point on that wave going up and down, again perpendicular to the direction of the propagation of the wave. The particle was not moving towards the shore, it was just bobbing up and down. So you have this transfer of kinetic and potential energy, where you have this maximum potential energy when the particle or the dead fish reached the peak of its oscillation, with a minimum kinetic energy or a zero kinetic energy, and then it starts to accelerate really fast to its maximum point at the center, and at that point you have a maximum kinetic energy and a minimum potential, and then it starts to repeat this. It goes below to the lowest part of the wave, where it now has the zero kinetic energy and maximum potential energy, but negative. And what this describes is when you have an interchange between kinetic and potential energy in the direction that is perpendicular to the direction of travel of the wave, which is exactly what happens over here. You have the classical definition of a transverse wave, and that's quite amazing to actually see what a transverse wave is when you have the transfer of kinetic and potential energy occurring perpendicular to the direction of motion of that wave. And that's exactly what's happening here. Quite amazing. Now, this is analogous to an electromagnetic wave, which works in exactly the same way. The direction of propagation of the wave is this sinusoidal function that's shifting in one direction, but the energy transfer between the magnetic and electric fields, between the magnetic and electric fields, are occurring perpendicular to the motion of that wave. And it's just very beautiful to be able to see that when you go to a lake, when you can actually see this phenomenon of kinetic and potential energy changing in a direction perpendicular to the direction of propagation of the wave. So I thought that was quite interesting.